Welcome back. In this video we're looking at quadric surfaces, and basically we're given the equations and they're not in standard form, but they can be put in standard form by completing the square. So we will complete the square, then once we've completed the square we'll see what type of surface we've got, we'll identify the center, and we'll sketch the surface for 3 different surfaces. Okay, so look at this equation. It may be a quadric surface. Notice that the x, the y, and the z are all squared. The first thing we want to do in any of these problems is we want to identify which variables are squared, and then if there's more than one term that involves that variable, like the y squared and the 4y, or the 4z squared and the negative 24z, we want to get all of those together, grouped, and we want to move the constant to the other side by addition or subtraction. So we're going to subtract 36 from both sides, and now that guy's gone. And over here, we want to group terms that have the same variable in common. Now there's no other x term, so I'll just write that down. And I want to group the y squared term and the negative 4y term. So I've taken care of these guys. I'm just going to check them off as I go. Group the y's together, and then we want to group the z's together. I've got a 4z squared and a minus 24z. And I should have left a little space to complete the square, but I think I can fit that number in there. That's fine. Okay. So now we are getting ready to complete the square on this one and this one. We always want to complete the square if we have that variable squared and a constant times that variable here. And we do. We have that for the y as well as the z. Now in order to complete the square, we need the coefficient in front of our squared variable to be a 1. We already have a 1 in front of the y squared, so that's great. That works out. But we don't have a 1 in front of this z squared. We need a 1 there. So to get rid of the 4, we're going to factor out a 4, not just from this guy, but from both of these two. So we'll factor out the 4 from that group. Just writing everything else down, leaving a bunch of space because I'm about to complete some squares. And I ask myself, 4 times what gives me the 4z squared? Of course, z squared. And 4 times what would give me negative 24z? Negative 6z. Okay, so now we look at the number in front of the y, or in front of the z. We call that b, and we use b to complete the square. So b is negative 4. Remember from pre-calculus, you take half of that, which is negative 2, and you square it. Negative 2 times negative 2 is positive 4. So we're going to add that to complete the square. Now, when I added that 4 to this set of parentheses, that made this a perfect square, but it also changed to the left-hand side. I added 4 to the left-hand side. So to compensate for adding that 4 here, I need to add 4 to the right-hand side as well. We'll do the same thing with the z's. Identify b, take half of it, and square it. Negative 3 times negative 3 is positive 9. Now careful here. You're not going to add 9 to both sides because you didn't add 9 over here. You add 9 in the parentheses. You added 9 in the parentheses, excuse me. What we really added to the left-hand side was this 4 times the 9. When I distribute that, I'm going to get a 36 over here. So since I'm adding a 4 times 9 on this side, I need to add a 4 times 9 on the other side. So I've got a 4 times 9 on the right to compensate for adding a 4 times 9 on the left. Now this quantity is a perfect square, and this quantity is a perfect square, so we will factor those. Bring my 4x squared down, not really doing anything with it. Simplify the right-hand side. Negative 36 plus 36 is 0. We just have a 4 over here. And this is a perfect square. It's y plus or minus something. To figure out what that something is, I take the square root of 4. So that's 2. And since that's minus, that's going to be a minus. Or you could just factor the traditional way. I'm looking for two numbers that multiply to give me 4 that add to negative 4. Negative 2 and negative 2 will work because negative 2 times negative 2 is 4 and negative 2 plus negative 2 is negative 4. So that is that factored. Also, this number is always b over 2. If you want to remember that as a rule, you can. Over here, we're going to do the same thing. So this is going to be z minus 3, according to the rule. Let's say we don't want to do a rule. We want to say, what two numbers multiply to give me 9 that add to give me negative 6? 3 and 3 will work if they're both negative. And notice that's the same thing I have here with the b over 2. Negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is negative 6. So we're here. I've got 3 variables that are all squared. I've got a 4 on the right hand side. I'd really like that to be a 1, so I'll divide everything by 4. So we get x squared plus y minus 2 squared over 4. And the 4 is reduced there, plus z minus 3 squared equals 1. What type of equation is that? I hope you noticed it's a 1. And the x, the y, and the z are all squared. Now since all 3 of those are positive, and we've got a 1 on this side, if I let z equal 3, I get an ellipse. And if I let y equal 2, I get an ellipse. And if I let x equal 0, I get an ellipse. So together, all of those are going to make an ellipsoid. Let's identify the center. X naught, y naught, z naught is what you're subtracting from the x, the y, and the z. We're not subtracting anything there, so x naught is 0. Y naught is 2, and z naught is 3. We always take the opposite sign from what's there. So we're going to go to x equals 0, y equals 2, z equals 3. That's our center. It's actually back here in the YZ plane. Alright, and what does this say? There's an implied 1 here, 1 squared in the denominator. You can think of that as a 2 squared, and that's a 1 squared. So we're going to go plus and minus 1 unit in the x direction from here. So you're going to go forward 1 and backward 1. And you're going to go plus and minus 2 units in the y direction. So you're going to go 2 units that way and 2 units that way. And plus and minus 1 unit in the z direction. So you're going to go up 1 and down 1. And you put all those pieces together, you end up with something that looks like this. And it went right through the coordinates of my point. That's okay, I'll just draw it over here, or write it over there. So we've got an ellipsoid. All the cross sections are ellipses. Or you can just remember, 3 variables are squared, all 3 are positive, and the right hand side is a 1. Okay, let's look at this next one. First, we want to group all the terms that have the same variable. And notice I've got a negative x by itself, and there's no other x squared, there's no other x term. So I'm going to bring that off to the side just for a second. And now I want to grab the y terms. I've got a 4y squared and a 16y, or minus 16y. Group those together. And then grab the z terms, z squared and minus 4z. All of that equals 20. The constant's already on the right hand side, so we're pretty much good to go. Now that's a y squared term and a y term, so we're going to complete this square here. And we've got a z squared and a z term, so we're going to complete the square here. No need to complete the square on the x. Now again, we need a coefficient of 1 in front of the y squared, so we're going to factor out a 4 from everything, just in those parentheses. 4 times y squared gives me 4y squared, and 4 times negative 4y gives me that 16y. This I'll leave alone. Okay. Now we're just going to complete a couple squares. Identify b. Take half of that and square it. Negative 2 times negative 2 is positive 4. Add 4 there. And actually that's going to be exactly the same. B is also -4 here. So we're going to add 4 there. Now make sure you're doing the same thing to both sides now. I just changed this equation. This is not even equal to this anymore. So I've got to compensate for what I did. That 4 did not add a 4 to the left-hand side. It added a 4 times 4. So I added a 16 to this side, a 4 times 4 to this side when I put that 4 there. So I need to add a 4 times 4 to this side. And over here, I added a 1 times 4, or just a single 4. So that needs to be added over there as well to keep everything balanced, to keep everything equal. So now we're here, and that's a perfect square, and that's a perfect square, so I can factor those. So I have -x, bring the 4 down. This is y minus 2 squared, because -2 times -2 is +4. -2 plus -2 is -4. So remember, that's how we factor. We look for two numbers that give us a product of this and a sum of this. Same thing over here. I need two numbers that give me a product of 4 and a sum of -4. So -2 will work. And then we'll simplify the right-hand side. So that's 20 plus 16. Is that 36? 36 plus 4 is 40. Okay. Now, since I have a variable raised to the first power, rather than, well, I'm going to try to get that variable by itself. Anytime you have a variable raised to the first power, it's helpful to get the variable by itself. So I'm going to add the x to both sides and subtract the 40 from both sides. And then we'll see what we get. We've got 4 times the quantity y minus 2 squared plus z minus 2 squared minus 40 equals x. Now this is not in quite the right form, but notice I've got two variables squared. The y and the z are squared, and x is raised to the first. So this is going to be, I hope you said, an elliptic paraboloid. Now that 4 is multiplying the y minus 2 squared. We're not dividing y minus 2 squared by 4. And that's okay. We just need to manipulate the equation a little bit so that we can have that number squared in the denominator to figure out how many units we're supposed to go in the y direction. Does everybody remember that multiplying by a number is same as dividing by the reciprocal? Or let's say it differently. If we're dividing by a fraction, isn't that multiplying by the reciprocal? So if I want to multiply by 4, I'll do this on a separate sheet of paper. Isn't that the same thing as dividing by 1/4? Because dividing by 1/4 is multiplying by the reciprocal, 4 over 1, and then I get that back. Make sure you agree with that, but that's going to give me that number in the denominator that I want. So this z minus 2 squared is fine. There's no coefficient, so we'll leave it alone. The minus 40 is just going to move things down in the x direction. Okay, so let's identify the center. X naught, Y naught, Z naught. Since X is raised to the first, we'll do that last. Y naught is 2. X naught, or Z naught is 2. And when X and Y are 2, these guys are gone. So X is -40. So this is not going to be to scale because it's too far away. But we're going to go 2 units in the X, or 2 units in the Y direction, 2 units in the Z direction. Got a little rectangular box that looks like this. And then we're going to go back 40 units in the x direction. So this is definitely not to scale. Okay, so that's rough, but that's basically what it is. We go 2 units, or back 40 to the right 2 and up 2, and we're right here at 2, 2, negative 40. Well, this says I want an elliptic paraboloid, and I know it's an elliptic paraboloid because the y and z are both squared and they both have the same sign out front. The terms are positive, and it opens in the positive x direction, but it's been shifted negative 40 units in the x direction. So it's been sort of shifted down in the x direction, or if you're thinking of the x direction as back, it's shifted back 40 units from where we are. So we're going to see like this. And that axis of symmetry is parallel to the x-axis. All right, let's do one more. Notice I've got 3 variables squared here, x, the y, and the z. And I've got an x term, a y term, and a z term by itself, those raised to the first. So we're going to complete 3 squares, group the x's together. So I've got an x squared and a minus 4x. I'm going to group the y's together. So we have a minus y squared and a minus 2y. And then group the z's together. We've got z squared and a minus 2z. Subtract 4 from both sides, so we've got a negative 4 over there. All right. Now, we're going to identify b, take half of that, and square it. That's what we add here to complete the square. If I add 4 there, that's a 1 times 4 on this side. I need to compensate by adding 4 on this side. Okay, on this one, I'm not quite ready to complete the square yet. I've got to factor out a negative 1. So I'm going to come back to that one. On this one, b is negative 2. Take half of that, it's negative 1. Square it. Negative 1 times negative 1 is positive 1. So we add 1 there. That means we add 1 over there. Okay, so now this is the quantity x minus 2 squared. Now from here I need a positive y squared, so I'm going to factor a negative 1 out of both terms, this one and this one. So we have a negative 1, I'm going to make it explicit by writing it as a negative 1, times y squared gives me the negative y squared, and negative 1 times positive 2y would give me negative 2y. We're going to complete that square, and this one factors to z minus 1 squared. Over here, we've got a 1 on the right-hand side for right now. Okay. Now here, our b is 2. Take half of b, that's 1, and square it. 1 squared is 1, so we add 1 on this side. Now we have not added 1 to the left-hand side. We have added negative 1 times 1. Negative 1 times 1 is a negative 1. So add a negative 1 times 1 over here, or negative 1 over here. And then you've kept everything nice and equal. Everything is all sides of our equation, the left and the right, they are staying equal to each other. I don't really need that negative 1 for emphasis anymore because I already did that thing. So I'm just going to change it to a minus. This is y plus 1 squared. 1 times 1 is 1. 1 plus 1 is 2. And 1 minus 1 is 0. Okay, so I've got a 0, and I've got 3 variables squared, and I got a 1 negative and 2 positives. I hope you said, that's an elliptic cone, Miss Townsend, and you'd be absolutely right. The 0 and the fact that there are 2 positives and a negative tell me that this is an elliptic cone. Let's identify its center. It's x naught, y naught, z naught. That's 2, negative 1, 1. Remember, take the opposite sign from what you see there. So we'll plot that point. We go 2 units in the x direction, minus 1 unit in the y direction, and up 1 unit in the z direction. So So we go up 2, back 1, up 1. That's our center point. Now this is a cone. Does it open parallel to the x-axis, parallel to the y-axis, or parallel to the z-axis? And how do you know? Well, remember, when we look at our equation over here, whichever term is negative, it opens parallel to that variable's axis. So this is, we've got a negative y term, negative y squared term. So our cone is going to open parallel to the y-axis. So it's going to open left and right. I'm just going to write for myself. Sometimes I'm not really sure from my pictures it's clear that that's like y-axis symmetry. It's actually not y-axis symmetry. Let me say it differently. Y-direction symmetry. Because it's parallel to the y-axis. It's not on the y-axis this time. Okay, so those are 3 examples of how we complete the square to write our quadric surfaces in standard form. Then we identify the surface and sketch them.